Before we get into today's example, make sure you have your periodic table to hand, your calculator, and we're going to recap the formula first of all. The formula is a really simple one. It is just simply moles is equal to C times V, where C is the concentration and the unit for concentration is always the same. It's moles per decimeter cubed, dm to the minus 3. And then the volume is V, and that must always be in decimeter cubed. So that means if you were given volumes that are not in decimeter cubed, you must convert. Now, you are normally given volumes in centimeter cubed. So, for example, if you're carrying out a titration or measuring solutions out, it's very common to talk in terms of centimeter cubed. So, I've measured out 25 centimeter cubed of HCl, or I've measured, 15 centimeter cubed of sodium hydroxide. So, we must remember that 1,000 centimeter cubed is equal to 1 dm cubed. So, what does that mean? If you're given the volume in centimeter cubed, you have to divide by 1,000. So, for example, a vol of, say, 25 centimeter cubed, dividing that by 1,000 gives us 0.025 dm cubed. These types of calculation come up in titration questions, acid-base neutralization questions, so very, very common there. But for now, we're just going to get practice at using this formula. So let's look at the examples. So in the first one, it says 0.2 moles of sodium hydroxide is dissolved in 250 centimeter cubed of water. Calculate the concentration in moles per decimeter cubed. Moles is equal to C times V. Rearranging, C equals moles over V. The moles is 0.2. The volume in decimeter cubed is 0.25. 0.2 divided by 0.25 gives us 0.8. Right, calculate the concentration in grams per dm cubed. Now, when we're faced with this, here's something else. So if I just highlight this in a different color, if you want to turn from moles per decimeter cubed into grams per decimeter cubed, it's really, really simple. So the relationship between moles, mass, and RFM is the solids formula, which is moles equals mass in grams divided by the relative formula mass of the molecule. So if I want to turn it from moles per decimeter cubed, just think about this as a unit, so moles per decimeter cubed into grams per decimeter cubed, I just need to change this bit. And I change this bit using that formula. It's really simple. So rearranging gives me mass equals moles times RFM. Or in other words, all I have to do is times the first answer by the RFM of the molecule, which is this. So I'm going to do 0.8 times the RFM of sodium hydroxide. So sodium is 23, oxygen is 16, and hydrogen is 1. So that's 23 plus 17 is 40. So 0.8 times 40 gives me 32 grams per decimeter cubed. Similar thing for the next one now. 5 grams of potassium nitrate is dissolved in 100 centimeter cubed of water. Calculate the concentration in grams per decimeter cubed. So first of all, this one is sort of a ratio. We could use a ratio for this one. So we know that there's 5 grams in 100 centimeter cubed. So if I want to find out what it is in 1,000 centimeter cubed, then we can see 1,000 is 10 times more than 100. So therefore, logically, the amount of potassium nitrate in 1,000 centimeter cubed, or 1 decimeter cubed, must therefore be 50. So all I've done is I've times by 10. So that's 50 grams per dm cubed. Then lastly, calculate the concentration in moles per decimeter cubed. Well, what we've got to do is we've got to turn that into moles. So that's the first thing. So moles is equal to mass over RFM. So the RFM of potassium is 39 plus 14 for nitrogen plus 16 for oxygen. 3 times 16 is 48. So 5 divided by, don't forget brackets on the bottom, 39 plus 14 plus 48 gives us 0.0495. So that's the moles. And then to work out the concentration, so concentration equals moles over volume. The moles is 0.0495. And then the volume is 100 centimeter cubed. Don't forget, we have to turn that into decimeter cubed. So 100, do here, obviously divided by 1000 is 0.1. So divide 0.1 gives us a final answer of, let's do this to 2 decimal places. That actually comes to 0.50. So 0.495 becomes 0.50 moles per decimeter cubed. What I've shown in these two examples before we finish is you need to be able to carry out these style calculations for, let me show you, where we have, say, HCl reacting with sodium hydroxide produces NaCl plus water, and you could be asked to find the concentration of say the sodium hydroxide. So you'd be given the volume of it. So say its volume is 20 centimeter cubed, and its concentration is, well, that's the question mark we're trying to work out. And then you would carry this out using the titration technique. So sodium hydroxide would be in the flask, hydrochloric acid would be in the burette. So I have covered this in another video. And then you would be given the concentration of this, let's just say it was 0.3 moles per decimeter cubed. And then the volume is the titer, how much we've used. So maybe we've put in, say, 32. And then you go ahead and you work out the moles of the hydrochloric acid, do the molar ratio, which is 1:1, and then work out the concentration of sodium hydroxide. This type of question is covered in my video called the 3-point process. And I've attached the link for this video below. So in order to do these type of questions, you've got to be able to do the basic number crunching here in the ones that I've just started out. Anyway, that's it for today. I hope you found some value in this video. If you have, please like and subscribe. It helps the channel immensely. And if you have any questions or you're stuck, just comment down below and I will help you. Otherwise, see you in the next one.